Hey everyone, and welcome to this explainer. Today we are unpacking a massive, honestly counterintuitive paradox that is literally breaking modern software engineering right now. We're looking at this wild situation where the AI tools we use every single day to write code are simultaneously making us faster, but also making us significantly more anxious. So let's dive right into this.
Think about this for a second. According to the Stack Overflow 2025 Developer Survey, which, by the way, polled over 49,000 developers across 177 countries, a staggering 84% of developers are now using or planning to use AI tools. That is a huge jump from just 70% back in 2023. We're seeing tools like GitHub Copilot sitting at 68% enterprise adoption. Now, naturally, you'd assume that a tool with near universal adoption is deeply relied upon and trusted, right?
Well, here's the kicker. Only 29% of developers actually trust the AI tools they're using. And the trend here is super alarming. Trust didn't just stay flat as adoption grew, it plummeted by 11 percentage points in just one single year. Let that sink in. We are using these tools more than ever before, but our confidence in them is completely collapsing.
Section 1. The Adoption Trust Paradox. Usage rises while confidence collapses.
The breakdown of this is just stark. 46% of developers actively distrust AI accuracy. That's right, distrust is the majority position. Only 33% trust it, and a tiny absolute fringe minority of just 3% highly trust the output. So you gotta ask, why use it at all? Well, pressure. It's competitive pressure, it's managerial pressure, and it's this relentless need for speed. Developers are basically forced to adopt it, making it the default workflow. And the result? 64% cite dangerously plausible, almost right code as their absolute top daily frustration.
Section 2. Why Trust is Collapsing. The 3 root causes of the gap.
Okay, root cause number 1 is a fundamental mismatch in how we engineer. Traditional software engineering is deterministic, right? The same input always equals the same output. But large language models, they're probabilistic. This creates massive cognitive friction at every single code review. You just can't easily internalize decisions you didn't actually make. In fact, in security-sensitive organizations, 66% of engineers are spending more time fixing AI code than they originally saved generating it.
Root cause number 2 is what we call circular AI TDD. This is when developers ask the AI to write the implementation and then ask it to write the tests. It's basically a closed loop. Non-deterministic agents totally break standard testing. Things like race conditions, hallucinated logic flows, and emergent coordination are just totally invisible to standard unit tests. So those green check marks you're seeing? They're hollow. They might prove internal consistency, but they definitely don't prove external correctness.
And root cause number 3 is a sprawling, massive security blind spot. Data from Veracode's 2025 analysis is frankly alarming. 45% of AI-generated code contains security vulnerabilities, and up to 62% present structural design flaws. Now, considering AI is currently producing 30 to 40% of enterprise code, this is absolutely critical. It's exactly why 78% of security practitioners now cite secrets exposure as their top new risk. The AI is just generating flaws way faster than humans can ever review them.
Section 3. The Architect's Paradox. Skipping the struggle.
So, what is the architect's paradox? Well, it happens when you skip the apprenticeship of actually struggling with the code and you jump straight to management. You tell the AI to build a system, and it happily goes off and makes 10,000 micro decisions about state management, error paths, and timeouts. Because you directed it, you feel like you built it. But you don't actually own that code base. This is exactly why the most frustrated developers right now are the most experienced ones. Senior devs have a 20% highly distrust rate and only a tiny 2.6% highly trust rate.
The end result here is that your code base basically becomes a Potemkin Village. You know, like those historical fake facades that look like thriving, bustling towns from the road? AI codebases look exactly like clean, perfectly architected production systems. But the moment you lean on them, the moment a real-world error occurs at 3 a.m., the whole facade collapses because there is zero connective tissue or deep understanding behind those walls.
Section 4. The Production Reality Check. Demos versus real-world systems.
There's this super uncomfortable gap between AI defaults and actual production needs. When an AI hits an error, it usually defaults to a simple print statement. But production needs structured tracing, like OpenTelemetry. AI loves in-memory state, which completely evaporates on restart. Production requires explicit distributed state locking. AI writes optimistic, synchronous code, but real production needs circuit breaking, dead letter queues, and exponential backoff. This gap? This is exactly where that 29% trust figure lives.
To make this completely concrete for a second, consider this highly specific example. By default, an AI will almost always write code that awaits a full response from an LLM API before displaying absolutely anything. In a weekend demo? Yeah, sure, that's fine. In production, that results in a 12-second blank screen for the user. A real engineer knows they need to implement streaming right off the bat. An AI agent, it just doesn't care.
Section 5. The Trust Architecture. 3 steps to reclaim ownership.
Okay, so how do we fix this? To transition from a vulnerable vibe coder to a resilient AI engineer, you've got to adopt 3 concrete workflows. We're talking about shifting to review mode, implementing chaos testing, and taking critical path ownership, which, by the way, actually starts by writing human-authored failing tests before you even touch an AI. Let's break these down real quick.
Step 1. Change the AI's role entirely. Right now, most developers use AI as a writer. It generates the code base. You need to flip that on its head. You must write the architecture and the core logic yourself, and then use the AI as a reviewer. Ask the AI to poke holes in your design, find edge cases, and challenge your assumptions. AI as a reviewer is dramatically more trustworthy than AI as an author. Step 2 is chaos testing. Look, real trust isn't built on green checkmarks. It's built on seeing a system break and knowing exactly how it recovers. You need to intentionally destroy your environment. Kill the database mid-request. Set your LLM timeouts to a single millisecond. Send total garbage, malformed JSON to your endpoints. Hit it with 1,000 concurrent requests. Doing this 20 times maps out your failure modes and builds that deep engineering instinct that AI generation honestly stole from you.
Section 6. Trust as a competitive moat. The economic reality of AI engineering.
According to the 2026 Project Discovery AI Coding Impact Report, 66% of security teams are now spending over half of their time manually validating AI-generated code. Think about the crazy economics of that for a second. Any velocity you gained in generation instantly evaporates because your senior engineers are sitting there meticulously checking for hard-coded secrets and structural flaws. So the ultimate takeaway is this. Hybrid ownership teams win. Teams that push AI generation to the periphery for the boilerplate stuff, but demand that human engineers completely own and handwrite the critical path, they're the ones who will close this velocity gap. They ship faster, and most importantly, they actually trust what they are shipping. That trust, that becomes an incredibly durable competitive advantage.
I want to leave you with a thought that perfectly summarizes everything we've looked at today. The future of AI engineering is not more generation. It is better ownership. Seriously, stop managing prompts, delete the AI code on your critical path, and start owning your systems again. So ask yourself today, are you building a resilient system or just a really fast Potemkin Village? Thank you so much for joining me for this explainer, and I'll see you next time.